digital twins is arguably one of our favorite buzzwords, right? So I'm intrigued to see a show of hands in the room, those of you who actually know what a digital twin is. Okay, that's a good fair few of you, so you're in the right session. And keep your hands up there for those of you who've created a digital twin. Okay, a few less of you there. Well, you could say that a map is a digital twin itself. So a digital twin is a virtual representation or digital replica of the real world. So it's used to model its real-world behavior or characteristics. And digital twins are all around us. It could be the likes of Meta using digital twins and virtual reality for surgical training. So here we're looking at complex procedures here using virtual organs to help upskill surgical staff and help reduce risks in the field. Or it could be the likes of Tesla here. So if you've ever been in a Tesla car, you can see that really smart dash cam. So what it's doing is it's using digital twins and photogrammetry. So using 2D images to translate this into a 3D scene. So we can see here that it's picking up cars and trucks, people, even traffic lights and lane markings. And this is really intelligent because it's using it to help drive autopilot and self-driving cars. And then, of course, there is Esri, where geography is at the heart of digital twins. So it's used with that spatial context to model relationships between objects and places. And here we're zooming into Buckingham Palace there, and we can see a map. So bringing in all those different places. We can bring in our buildings and have this 2D concept, which is alike to a digital twin here. And as we zoom in, we can start to extrude these out into 3D. So these buildings really come to life here. So as we're looking at this area, we could walk along this road, which you might have taken today to get to the QE2. We can see all of these extruded buildings, but also bringing the likes of OpenStreetMap trees in and really starting to create this picture. We have the QE2 there on the right, but as we spin around, we can start to see even richer levels of detail, so the likes of Westminster Abbey here, or we could see Big Ben, so really bringing in this richer level of detail. And this is incredible to create this immersive digital twin to then share with stakeholders. This could be for public consultation or for helping with different inspections. And so we heard before from the University of Warwick around the digital twin maturity levels, and we heard it again last year from Mark. So there's different levels of digital twins, and these are all tied together through a digital thread here. So it could be anything from descriptive here at the bottom, so creating that baseline digital twin with the likes of reality capture, virtual models, and also 2D or 3D visualization. This can then be built up and bring in the likes of real-time data and AI all the way to an autonomous digital twin with that self-learning and decision-making. And in today's session, we're going to focus on this baseline digital twin. So how can we create that conceptual model to then build up in the future? So we'll start off this technical session looking at how you can make the most of your data in 2D. What good quality data do you already have, and how can you help make decisions? But then how can you start to elevate this digital twin into 3D? So using some of our out-of-the-box tools. And lastly, creating an immersive 3D view. So bringing together disparate data, so the likes of imagery, LiDAR, and BIM to create this immersive environment. And the key takeaway I'd like you to take away from today's session is that it's simple for anyone to create a digital twin. So let's get started having a look at some examples here. So here we can dive into our infrastructure project. So I'm sure this is one that many of you recognize running from London to Birmingham. We can jump into this Birmingham section here where we can see these safeguarding areas, so understanding areas of the project and how it impacts surrounding infrastructure or demographics. And we can start to bring in other data here, like the proposed scheme data. So we can see an embankment here. And as we zoom in, we can start to see a flood compensation area. So building it up with all of this great amount of data. And as we jump to the end here, we want to better understand the impact on those surrounding households and demographics. So here I can bring in census data of household demographics from the Living Atlas. And here we've used smart mapping to automatically understand our data. So here we've got counts and amounts with our choropleth data. We could also change this to dot density, so one of my favorite here. So we've got a one-to-one value. Now, if I zoom out, what we can see is that we've got a high concentration of households along this area. And as we zoom along the project as well, we can start to see we've got a high proportion around Aylesbury. So we'll come back to that a little later there. But jumping back to our data, let's change this back to our original choropleth there. Now, it's great to see this data, but how can we better understand the impact on those neighboring infrastructure? So what we can do is we can start to bring in our OpenStreetMap Buildings for Europe data. So this is a freely accessible data set in the Living Atlas. And what we can start to do is we can play around with some of the cartographic tools here. So what I've done is I've now overlaid this data onto our buildings data set. So just quickly jumping into this, I've used some of our blending tools to understand both that census and OpenStreetMap buildings data. So we've got a whole host of ones for you to choose from. If I look at overlay, we can see how those two data sets are being merged together. But for this instance, I'm looking at that source at top. So we can see there we've got a really nice visual insight into understanding our project. But how can we get a more quantitative analysis? Now, if I select onto these sections here, what we can see is this dynamic pop-up. So we can see here planning considerations need to account for 4,005 households within that surrounding area. Now, if I jump to that neighboring one here, we can see that this is jumped up to 6,655. Now, this was quick and simple to create with the likes of pop-ups here. So essentially what I've done is I've used attribute expressions and some arcade, so the ArcGIS expression language, to not only just understand those sections of the project, but also bring in other data sets on the map. So if you look at the profile variables, a little tip here is jumping into the map and we can start to spoof into those different layers. So here I've brought in that census data with feature set by name. I've intersected them, summed them, and created that total impact. So we've got a good insight into our data. But now let's elevate this into 3D here. So here we're looking at our project with the same data. I've got our OpenStreetMap data, but I may want to shift this to something a little bit cleaner. So we've got terrain with labels here, and this is in WebMacator, but an exciting new enhancement is that we've now released in beta the British National Grid terrain base map, so you can bring this into your scene viewers and start to bring in your British National Grid data. But for this demonstration, you may have seen that 3D base maps there. So I can jump in and switch into our OpenStreetMap 3D base map here. So we can see this build up, and out of the box, I'm able to see all those buildings in the surrounding area. But I want to better understand this within my infrastructure project itself. So what I can do is I can start to create a mass. So let's just switch off those buildings here. And what we can see is I can start to snap it to the data that I already have on my project here. I'm doing this nice and roughly here. We can see here that it's starting to snap the data. Now, if I turn those buildings on, what we can see is that we're seeing the data outside of this area. And I can quickly switch this to show inside. So now I've got a really nice visual cue of our data. I can go and interrogate this further with some of the 3D tools available, like line of sight here. So I may want to understand the impact of a certain building to that infrastructure project and that line of sight, as well as different elements like dimensions here. I can also want to include more contextual information into our data set. So what I've done here is I've brought in the OpenStreetMap buildings data, and we can see here we can now understand those which are residential, industrial, retail data. So how I've done this is really quick and simple. So it's understanding that data. It would have come in as a 2D type, but I'm able to easily extrude that out into 3D. So I've set a specific height here, but you can use one of your attribute data sets as well there. We can also zoom into certain areas here and start to bring in 3D symbols. So we can see here for the proposed areas, I can add in some trees for planting and really bring this even more to life. Now, I mentioned before around Aylesbury having a really high concentration of households, so let's dive into that section here. Now here what I really want to focus on is how we collaborate with different organizations. And we started to see that with the University of Warwick's utilities data before. And so we want to better understand how we can work with different teams. I can jump into our Aylesbury University here and we can start to see that BIM model come through. So let's just start to manipulate our base map here so we can start to see that. And what I can do is I can quickly mask it out so we can see our BIM model. So ArcGIS natively ingests the likes of Revit, IFC, DWG, DNG. It's really performant from that aspect. And we've also got a great relationship with and partnership with Autodesk, so some connectors from that way. From our building levels here, we can start to interrogate this floor by floor. Or we can start to see the different disciplines and categories that have been brought through. So we can see architectural has got all of these different assets on. We can start to remove that and just drill down into that structural data. And as I select on an asset, it's pulling through all of that information that's come through from that Autodesk world. And so it's really trying to minimize that data conversion. Now let's just flick this on for the demo here. Now, you may have also noticed that we have some red lines here. So we're actually pulling through some utilities data. If I dive into the data set here, ArcGIS Online is understanding it's a linear feature and on the fly providing this smart mapping. So I can bring this down into 3D here. As we jump into the options, I can set the diameter as our attribute type here. Now, as you can see, this is obviously above ground, so I can start to manipulate this data so it's going below ground. And whilst that has just removed, if I just do a quick switch of the transparency there of the base map, we can start to see it underneath. Or as we saw before, we can start to go below ground with our utilities data and buried services. Now, a quick tip for this is just making sure that on your ground level here, that we configure the ground to include that underground navigation. So a quick one that you may forget there. And lastly, I wanted to point out the fact that ArcGIS Scene Viewer now includes real-time data. So we no longer need the JavaScript 4 API, it's all out of the box. So we can start to bring in our Waze data here and see that we've got a roadworks closed until April 2025. Then we can start to see this against the digital twin of our utilities data and start to think about safe digging and making sure that you're collaborating really well with all those different organizations. Now, lastly, let's jump over to London Euston for the end of our project. And here we could be looking at a build phase here, so we can start to see that proposed scheme. So I'm just going to flick off that layer for now. And what we can see is Blue Sky's imagery data here for Euston. So really high resolution, and I'd just like to point out this is from 2020, so this area has evolved since then. But this can be really great for off-site inspections or also starting to manipulate this data. So if we just dive into our mesh here, we can start to configure modifications. So I might want to remove some of these buildings here as it's evolved and I want to bring in a new sketch. And I can just simply replace this, and we can see here that it's now removed those buildings. I can start to add in my sketch here. And we can see here it's really bringing this digital twin to life. Now, this is just an example for this demonstration, but you can really start to see how you can build this up to work with different teams and organizations. We can also start to bring in LiDAR data as well. So this was taken from DEFRA's open platform. So here we may use these sorts of data sets for more high accuracy inspections. As we dive into this data, we can see that this is being shown by elevation there. But we can switch this over to class so we can start to see the ground and the buildings and the different vegetation. So we may want to do some use cases like vegetation encroachment on the infrastructure, or even thinking about biodiversity net gain. And then lastly, what we can do is we can dive into other areas. So we've mentioned that we wanted to create this really immersive digital twin. And using all of this data and this 3D model, we can start to bring in the likes of the glossy water here, and we can see that reflection of the O2 on the Thames. We can also go back as well to where we started here, so back to the QE2. And what we can see is that we've created this really immersive digital twin for stakeholders to be able to engage and make decisions. You would have seen this view as you've walked in today, and this is just bringing a few different data sets together. So jumping back to our slides here, and just to reflect on today's session, what I've shown you is how to make the most of your data in 2D. So if you've got good quality data, you can already make some brilliant decisions and start to leverage tools like blending for visualization or Arcade for quantitative analysis. We could then start to elevate this into 3D and use some of our out-of-the-box tools. So it could be extruding buildings or utilities or bringing in those 3D base maps. And lastly, you can create an immersive 3D view with disparate data. So bringing in LiDAR, imagery, and BIM, all of these together into this interactive performant application. And so the key takeaway, as I mentioned at the start, I'd like you to get out of this is that it's really simple for any of you to go away today and start creating a digital twin. So I hope you've picked up some tips and tricks from today's session, and I'll be around at the tech session stand later if anyone's got any questions. So thank you very much.